The scheme is applied for the protection of radial feeders, parallel feeders and ring mains. So we have to protect देखो the fault the system in which the fault occurs. So ਅਸੀਂ ਉਸੇ ਸਿਸਟਮ ਨੂੰ ਪ੍ਰੋਟੈਕਟ ਕਰਨਾ ਜਾਂ ਉਸੇ ਪੋਰਸ਼ਨ ਨੂੰ ਪ੍ਰੋਟੈਕਟ ਕਰਨਾ ਸਭ ਤੋਂ ਪਹਿਲਾਂ ਜਿਹੜੇ ਪੋਰਸ਼ਨ ਦੇ ਵਿੱਚ ਸਾਡਾ ਫਾਲਟ ਪਿਆ, ਸੋ ਦੈਟ ਦਾ ਫਾਲਟ ਕੈਨ ਨਾਟ ਟਰੈਵਲ ਟੂ ਦਾ ਅਦਰ ਸੈਕਸ਼ਨ ਆਫ ਦਾ ਸਿਸਟਮ. So we are to protect the limited possible system, limited possible section to protect the system and to clear the fault. So this system is used for radial feeders, then this is used for parallel feeders, and this is used for ring mains. So then we have time graded protection for radial feeders. Now how we can choose this system? Time graded protection. The time graded protection feeder is obtained by implying inverse differential minimum time lag relay. So we have one type of relay is known as inverse differential minimum time lag relay. The relay are so set that the minimum time of operation decreases from the power station to the remote substation as shown in next slide. मैं तुहानू दसांगा. So this is the point to note. The relay are to set the ਜਿਹੜੀਆਂ relay ਉਹ set ਕੀਤੀਆਂ ਹੁੰਦੀਆਂ the minimum time of operation, the minimum time of operation of a relay decreases from the power station. So that power station ਤੋਂ ਉਹ ਰਿਲੇ ਦਾ ਟਾਈਮ ਡਿਕਰੀਜ਼ ਹੁੰਦਾ ਟੂ ਦਾ ਰਿਮੋਟ ਸਬਸਟੇਸ਼ਨ. ਸੋ ਅਪ ਟੂ ਰਿਮੋਟ ਸਬਸਟੇਸ਼ਨ ਤੱਕ ਐਜ਼ ਸ਼ੋਨ ਇਨ ਫਿਗਰ. ਸੋ ਨੈਕਸਟ ਸਲਾਈਡ. The operating time of inverse definite minimum time lag relay is inversely proportional to the operating current but is never less than the minimum definite for which it is set. So ਇੱਕ ਖਾਸ ਟਾਈਮ ਤੋਂ ਇਹਦਾ ਟਾਈਮ ਐਕਸੀਡ ਨਹੀਂ ਕਰਨਾ ਚਾਹੀਦਾ. So again the operating time of the inverse definite minimum time lag relay is inversely proportional to the operating current but is never less than the minimum definite for which it is set. So this is time graded protection. So you can see we have a generator. Immediate after generator we have a step up transformer. So this is our transmission system ਸ਼ੁਰੂ ਹੁੰਦਾ ਇਹਦੇ ਵਿੱਚ. In power system ਦੇ ਵਿੱਚ we have a generator, we have a very big transformers where those transformers are installed at generating stations near the generators. So after that generator you can see there is a circuit breaker A. So this circuit breaker, the time of operation of this circuit breaker is 2.1 second. So the next there is a feeder. After traveling some distance there is another circuit breaker B. The relay time of that circuit breaker is 1.6 second. So the relay time of the circuit breaker C is 1.1 second. The relay time of the circuit breaker of circuit breaker D is 0.6 second, and the circuit breaker E is operate if the fault occur, the circuit breaker E will operate after 1.1 second. So this is time graded protection. This is known as time graded protection. So if fault occurs between section E and F, so you see, let us say now the fault occurs between section E and F, it will be cleared in 0.1 second. So you see this fault, that's why the circuit breaker at point E, the relay of the circuit breaker will be operational after 0.1 second, and after 0.1 second it will operate the trip coil of the circuit breaker E. So in this way when the trip coil of the circuit breaker circuit breaker E operate, so this will operate the circuit breaker E and the fault is cleared by this circuit breaker within 0.1 second. So by the relay and the circuit breaker is substation of E, because all other relays have higher operating time. So you see all the other relays have a higher operating time. So that is why only the circuit breaker at point E will operate. So at all relays having higher operating time, if the relay at substation E fails to trip. So now these are all the defense protection. ਜਿਸ ਤਰ੍ਹਾਂ ਅਸੀਂ ਸਾਡੇ ਬਾਰਡਰਸ 'ਤੇ ਅਸੀਂ ਆਪਣੇ ਬਾਰਡਰਸ 'ਤੇ ਡਿਫੈਂਸ ਲਾਈਨ ਯੂਜ਼ ਕਰਦੇ ਹਾਂ. So let us for example we have a border at Wagah. So we have a one defense line at Wagah border. So it doesn't mean that all forces of our Indian forces are or are employed at Wagah border. So we keep our 75% forces spare to be employed at Amritsar, and rest of 20% is employed at Jalandhar, and rest of the forces at various different situations to protect our capital, to protect our different cities. So similarly, if we are protecting our country in this way by the defense system, similarly our costly equipment at the generating station are again protected by these relays, and the timing of these relays are set in a sending and descending order, like how the system is to be protected. So if the fault occurs in the section E and F, though the relay at of the circuit breaker E will operate and the fault will be clear in a 0.1 second. So if you see the relay cannot operate, so if the circuit breaker the circuit breaker relay E is not operating, if the relay at the substation E fails to trip, the relay at D will operate after a time delay of 0.5 seconds. You see the fault will travel. Now the fault current will travel from E to D, then D to C, then C to B, then B to A. So it will go on damaging all the equipments, all the system. So if it is traveling further and further, so then we have again defense line at D. So our relay D will operate. If the relay E is unable to operate, the relay D will operate after 0.5 seconds, means the total time is 0.6 seconds. So after 0.6 seconds from the occurrence of the fault. So in this way we protect our time graded protections. So then we have time grade protection for parallel feeders, where continuity of supply is absolutely necessary. Two feeders are run in parallel. If a fault occur on the feeder, the supply can be maintained from the other feeder, disconnecting the faulty feeder following. So I have again shown in the figure, next slide ਦੇ ਵਿੱਚ ਤੁਹਾਨੂੰ ਮੈਂ ਦੱਸਾਂਗਾ the system when two feeders are connected in parallel between generator station and substation. So at the generating station, non-directional overcurrent relays are connected, whereas directional overcurrent instantaneous relays are connected at substations end. So this is one of that. You can see we have a feeder number 1, we have a feeder number 2. These two feeders are parallel and connected to a common bus bar. So this is known as parallel feeder protection, though if the fault occurs at feeder number 1. So similarly, so time graded protection for parallel feeder. So if an earth fault occurs on feeder at point F as shown in previous slide, so directly from feeder 2 via relay B, from feeder 1 via A, P and substation Q and shown. So you can see over here. So this is the fault, how the fault current is flowing. So this clearly shows that the directional relay P carries the current in the normal direction, whereas the directional relay Q carries the current in the reverse direction momently. This operates the relay Q instantaneously. The relay B, having inverse time characteristics, also operates because of heavy flow of current. So the protection of, again we have ring main system. You can see this is our ring main system. So ਇਹਨੂੰ ਅਸੀਂ ਕਿਸ ਤਰ੍ਹਾਂ protect ਕਰਨਾ, the system in which various protection station, power station and substations are interconnected by a number of feeders forming a closed circuit is called ring main. In this system The protection of non-directional overcurrent relay having inverse time characteristics are implied, whereas directional and reverse power are employed on the both the sides of the each substation. The minimum definite time of all the relay are set properly as shown. You can see in this figure. In this figure you can see this is a time graded protection for ring main system. So now we are adopting this system, whereas the fault occurs on any one of the section, only corresponding relay will operate within distributing the other relays, so without disturbing the other relays of the network. Thus the faulty section is isolated and the supply is maintained. So whenever there is a fault, so if the fault, let us say if the fault occurs at point in between the point C and D, so only the relay C will operate, and the faulty section C D will be isolated, and the rest of the section will be working. So this is very reliable. So then we have differential protection translay relay schemes. The translay schemes is basically a voltage balanced differential protection scheme, but in this scheme voltage induced in the secondary winding wound on the relay magnet is compared in place of secondary voltage of the line current transformer. The schematic diagram of translay scheme for the protection of three-phase feeder is shown in the next slide. So the relay used in the scheme is essentially overcurrent induction type relays. So we have this overcurrent protection type induction type relay. The center limb of the upper magnet carries the winding, which is energized by the sum of the secondary current of the CTs applied on the feeders to be protected. So we are going to protect the feeder. You see the upper three feeders. So these feeders are protected by the relay of these two instruments. So total transformer CTs are 6, and all these CTs are connected to the relays. So then we have a differential protection construction. So the central limb of the upper magnet also carries a secondary winding B and B dash, which is connected in series with the operating winding C and C dash placed on the lower magnet. So in between the two magnets, an aluminum disc D is placed, which is free to rotate. Spindle of the disc carries moving contact, so which closes the tip circuit under fault conditions. So this is the diagram, and this is the explanation. So differential protection. So in this way I have already told you we ਅਸੀਂ differential protection अपने feeders ਦੀ ਕਰਦੇ हैं, and this is all for the day, dear students. So I all of you, for me, I congratulate you that the examinations are near and you may pass all these subjects from examination point of view. Thank you very much.